Good evening. Thanks for joining tonight's TI Technology webinar hosted by Text Instruments, where tonight we're going to focus on AP Precalculus. We've done a few of these other AP Precalculus specific webinars, but tonight we're going to focus on rates of change. My name is Mike Houston. I'm the moderator for this event. I teach algebra and calculus near Pittsburgh, where I use TI technology to make tough to teach, tough to learn concepts accessible to all my students. And tonight I'm really excited to be joined by our two panelists, Vicki Carter and Karen Slino. Vicki recently retired after teaching high school math for 46 years at West Florence High School. She's a former co-chair of the AP Calculus Development Committee and served in various leadership positions at the AP Calculus Reading. She received the T-Cubed Leadership Award in 2015 and has served on many TI-Nspire authoring teams and presented at lots of conferences, national, state, and local. Vicki, it's great to have you with us.
Thank you. I'm going to enjoy presenting this tonight.
And Karen is a 33-year veteran high school teacher in Flushing, Michigan. She's taught AP Calculus for 27 years and AP Precalculus for 28 years, the last three being AP Precalculus. So she taught Precalculus for 28, the last three being AP. Karen's been a consultant for the College Board for the past 9 years and is excited to be a TQ regional instructor for us as well. Karen's primary focus is allowing students to experience the mathematics before she fills in the gaps. Most recently, she was thrilled to be honored with a Presidential Award for Excellence in Mathematics and Science Teaching in January this year. So huge congratulations, Karen, for that. And in her free time, she enjoys attending Broadway shows, dining at fun restaurants, and reading books to improve her teaching skills. So Karen, thanks for joining us.
Thanks so much, Mike. I'm so happy to be here.
All right, Karen, what are we going to do tonight?
Well, we've done the welcome and introductions, so we are going to jump into talking about this phrase, rates of change, what that's all about in AP Precalculus, and why we want to use that language instead of slope. We will also talk about applying technology to that topic of rates of change, and also how do we help our students to communicate about rates of change in the way that they would need to on the AP exam. We will also wrap up then by talking about how teaching AP Precalculus has really affected students in AP Calculus. So I will share some anecdotes what's happened in my classroom. And then, of course, we will have the webinar drawing for the calculator.
Thanks, Karen. And Vicki, what can we expect to be able to do by the end of the webinar tonight?
Well, we have several things that we want to make sure the participants can do. And first is that you can communicate about rates of change in AP Precalculus. It's a little bit of a new world from what you might have thought of in a traditional Precalculus course. And as Karen says, it definitely leads them to calculus concepts, and she'll share some of that with us toward the end. That you can give reasons for your answers using the necessary language of AP Precalculus, which is very important. That you can use technology to visualize rates of change. You can use technology to explore zeros and end behavior with polynomial functions. And then we hope that you'll be able to access files from this webinar. Mike, were you going to add something with this accessing files?
Yep.
Here?
So
Okay.
I think Vicki and Karen did a great job. They're going to have some links that are going to be available in the chat window throughout the webinar tonight. If you happen to miss them for any reason, I know sometimes the chat window goes flying by, or maybe the links aren't working for whatever reason. If you just hang tight, you'll automatically get a follow-up email, which will also contain a link for the documents. And these two ladies actually put all of those links into one document. So you'll get them either in the chat window tonight, or if you're watching this later, you can download the documents and there'll be a file that just has all the links in it. So I'm excited about that.
Thanks, Mike.
Thank you. And tonight we're going to use that chat window. We've already started talking about that. As a reminder, the session is being recorded, and we'll provide a link to the event certificate of attendance as well as the documents at the end of the webinar. So Karen, let's see what you got.
All right, let's go. Okay, so to begin, Vicky, would you like to talk about the Facebook group?
Yes, I will. So we do have a Facebook group. It's called AP Precalculus Teachers. We would love for all of you who are teaching AP Precalculus to join that group. You do need to answer 3 questions and agree to the group rules, or it'll automatically um, tell you that you can't join. So make sure you do that. Chat window, I am going to put the link to that, and this will also be in that document that Mike was referring to if you want to work on that later and not have to deal with that tonight.
Excellent. All right. So the first question, of course, we need to ask is why are we talking about rates of change? Why did Vicky and I decide that needed to be the key for this entire webinar tonight? So to begin, though, we would like to know what your experience with AP Precalculus is. So in the chat, if you could tell us how long you've been teaching AP Precalculus. So I guess that means from 0 to 3 inclusive, right? Just so we have an idea who's in the house tonight.
Oh, wow. I'm seeing quite a variety here.
We really do have a variety. That's right. We've got some zeros, we've got some threes, and everything in between, too. Fantastic. All right. Thank you for sharing that. So to begin, when we take a look at our course and exam description for AP Precalculus, I thought I would go in and just see how many times that word change appears. And believe it or not, it is in the CED 195 times. It's an important concept. In fact, I would say it's probably one of the biggies that follows the entire course, because no matter what type of function we're talking about, we are talking about change and how is that change happening, and we're communicating that. So as you see on the screen, these are some of the topics where we are looking at change, from just linear and quadratic functions to polynomials to sequences to exponential and log functions and to polar and parametric functions. So change is a really big idea. And I'd also like to remind us, if we're new to AP Precalculus or AP at all, is that when we're teaching a concept in these courses, we want to follow the VNAG model. So this is what we are thinking about. First of all, we want to make sure our students can handle any kind of question that might be delivered verbally. So can they read the words and know what's being asked? Can they also answer the question numerically if they've been given a table of data? What if they've been given the actual equation and they're solving analytically? And then finally, graphically. So we need to be sure that whatever the concept is, that we are presenting it in these four manners, so that our students gain application and practice with doing this, because on the AP exam, they will meet all of these different formats. Tonight, we're really going to focus on the verbal, the numerical, and the graphical. So let's jump in. So this is a really typical sort of question that I would be asking my students in early AP Precalculus. In fact, that's what we're talking about right now. And so I would say we have a table of data, and we know that this change in tandem idea means as our inputs are changing, our outputs are changing. And we would like to know more about this relationship. So the first thing we always need to do is to take a look at the input column. And I should mention here too, you'll notice I'm saying inputs and outputs. And if you're new to AP Precalculus, that may feel very awkward to you. But in this course, those are the words that we'd like to use instead of X and Y or independent, dependent variables. Those are still important, but we talk a lot about inputs leading to outputs. So what I notice when I look at these inputs, what do you see here, Vicki?
I see equal width input value intervals.
What did you just say? So if you read the CED, that's exactly how we describe those inputs. And that's how we need to get our students talking to, is to look at those and say, not just, oh, we're adding one each time, but to talk about those consecutive equal length input value intervals. So now that we've thought about what the inputs are doing, let's take a look at the outputs. And as we look at those outputs, we might notice that we have a consistent increase of 4. So that's telling us something about the relationship here. How do we get our students to talk about that? Well, this is what we have to get them to say eventually. As those inputs increase at a constant rate over equal length input value intervals. The outputs increase at a constant rate, so therefore this function appears to be linear. So the first time my students see this, they say, "What are you talking about?" But the more we do it, the better they get at it.
And Karen, I also think it's important that while you're talking about these outputs increasing at a constant rate, that you also refer to first differences. You might not do it this first time, but you're going to see here shortly that sometimes we need to do second differences and third differences. So I think those help the students make connections with the kind of function they may be viewing in that table.
Absolutely. So since you mentioned second differences, let's take a look at a new table. All right, so the first thing, of course, we're going to do is take a look at that input column, and we notice again that we have consecutive equal length input value intervals. And the more we say it, the more it gets embedded in our brains too, right? So that's happening, but now what's going on with our outputs? And this time, when we look at those first differences, we notice they are not all the same as they were last time. We notice there's a pattern to them immediately, but they are not all equal values, which is telling us this is not a linear relationship here. So now what we will do is move to those second differences, and we notice now we have a constant second difference. So now our students would respond, well, as these inputs increase at a constant rate over equal length input value intervals, the second differences are constant. So this function appears to be quadratic. So this is something students probably have not done in their math courses up to this point. So speaking this way is difficult, and also being able to analyze what they see in a table can be difficult too. So they need a lot of practice with that. Let's move on. So this question comes courtesy of Mathematic. We are again looking at a table, and we know that this is a polynomial function. So we have a little bit more information. So usually when we know we have a polynomial function, we might wonder, well, what's the degree of this polynomial function? So that's what we're going to figure out in this situation. So again, the first thing we do is we look at our inputs, and we notice right away we have consecutive equal length input value intervals. So now let's focus on the outputs. And as we start building those differences, we notice the first differences don't match, the second differences don't match, the third differences don't even match. It takes us until we get to the fourth differences that we have 384 both times. And what that's telling us is that we have a degree 4 polynomial. So once the students get the idea of what's expected here, they kind of run with it and they do great. But at the beginning, it is a slow go, definitely. So I think we're going to now switch things over to Vicky so she can help us see, well, how do we bring the technology into a question like this?
So what I'm going to demonstrate tonight is the TI-Nspire. We talked about it. We have an awful lot to present to you tonight. So I'm going to write up some instructions for how you could do this with the 84. And it'll be posted, as Mike said, when you get that email that says the recording is ready, then it'll be one of the documents that you can download. Okay, so I actually decided I'd go back to the one before this and talk a little bit. And what I have is the 3, 4, 5, 6, and 7 as inputs. One of the things about the TI-Nspire that I would encourage you to do, and by the way, you can get a demonstration copy to use on your computer at school, even if your students don't have the TI-Nspire to use in the classroom. So one of the things that I was taught early on is to not give single letter names to your columns in this case. And I actually use the language that Karen has been using, the input and output. And so I have taken the liberty of already inserting those values in the 3, 4, 5, 6, 7, and 10, 12, 16, 22, 30. And what I want to do is actually have the calculator calculate these differences. Now, we know this would be a simple one for students to do, but if you think about that one that Karen had with the fourth differences, oh my goodness, the subtraction and the arithmetic and that one might get a little bit crazy for these kids, and so they might really appreciate being able to do this. So what I'm going to do is click into my kind of formula cell here, and I'm going to put an equal sign because I need to calculate these first differences. And I'm just going to show you how to access this. Over here where my cursor is, there looks like a kind of an open book. It's a catalog of all the functions that this calculator has. So I'm going to click on catalog. If when I initially do this, it starts at the A's. I can scroll down. What I want to do is get to the D's, and I want delta list. We know that delta means difference. As the kids progress to calculus, they will start talking about delta y or delta x, and then seeing how this, through the definition of the derivative, leads to a derivative, but we're not there yet. But this is a very powerful tool that so I'm going to select delta, and all I have to do is type output. I can also access it through the variables key, which is on the calculator keypad right here. But I'm one of these old school people that likes to just type it. It will turn bold if it recognizes it as a name that you have given something, in this case, that column. And when I press enter, there are my differences. And what's really cool about this is that I can go to the next column, and I'm going to call this diff 2 or second differences. And all I have to do is equal and catalog, get delta list. But this time I want the difference of the differences. And so there's our 2.
That is so cool.
Yes. All right, Karen, we haven't talked about this question yet, so I'll stop sharing so you can go back and talk about this next one, and then we'll come back and look at it, okay?
Okay, that sounds good. Okay, so now we are going to bring in another concept that I've never taught in AP or in pre-calculus until I taught AP pre-calculus, and that is concavity. So again, we are looking at a table of points. This question came from the Algebros at Flipped Math. And as always, the first question we have to ask is, what are the inputs doing? So when we take a look at our inputs, we see, again, they are all equally spaced. So let's focus on the outputs. So we could keep going with our second and third differences and go from there, but we have a different thing that we would like to think about this time. We are noticing that the inputs are increasing by 2. We are noticing the outputs are increasing by 1, and then by 3, and then by 6, and then by 9. So we would like to ask you, what is this telling us about the graph of g of x? And go ahead and write in the chat what you're thinking, what's happening here?
See some really nice comments. I think people have, at least those of you who've been in school for several weeks, have probably gotten to this in your classroom.
Mm-hmm.
Oh, we have a nice one, concave up, because the output value, the differences, the rates of change are increasing.
Love it. Yeah, this is great.
Yes.
So some of our students will just look at this and say the curve is concave up, but some will actually get a little better at that and say, well, wait a minute, what are our rates of change doing? And the reason that we have a concave up curve here is because those rates of change are increasing. So eventually we'll be able to look at a graph and choose any interval and say, we can see in this interval, the graph is increasing at an increasing rate, or increasing at a decreasing rate, because we're now thinking about how is that change happening. And that's the beauty of concavity, which of course we've not talked about in previous pre-calculus courses probably, but we do now. And so we can talk about concavity and inflection points. So when you introduce those then in AP Calculus, the students already know exactly what you're talking about. Okay, Vicki, did you want to demo this?
Well, we can. I mean, it's still using the same functionality. So I
Should
kind
we
of
move
think,
ahead? Okay,
yeah, let's
okay,
just move ahead.
let's move ahead.
They
Sounds
can
good.
they can replicate it with what I've already showed them.
All right, sounds great. So our next step in the journey is now talking about how do we help them communicate this? Because we've already seen this whole talking about what the inputs are doing, talking about the rates of change is not a comfortable thing for students generally. So I made a Quizlet the first year I taught this course to help them practice. And what you're seeing on the screen right now is the one of the test versions. So Vicki, if you could put the link for that Quizlet in the chat. This is one of those links that will be in the document you will receive later as well. But if you want to add this to your library, you're welcome to do this. You'll notice some of the things that we have here we haven't talked about yet, like multiplicity and things like that. But all of these things are represented in Unit 1 of the course. But it's really going to get students thinking about, okay, when I see that an F is concave down, what exactly does that mean? What should I be thinking? How should I describe that? Or if I hear there the rate of change is negative and changing at an increasing, what does that mean? So that's one way we can help our students with this Quizlet. Another way is to create some multiple choice questions and say, okay, as X is increasing, Y is decreasing. What does that mean? What's happening? Or if the rate of change is decreasing, what does that mean? So all of these things you can do with a Quizlet set of cards. So that link that's in the chat right now will take you to the Quizlet. And then if you want to just play the game with the students, you can, or you can make a document like you're seeing here. So I hope you find that useful. All right, so let's take a look now at a question from the CED. So this is how our students might meet this sort of language on the AP exam. And this is a multiple choice question. So first we have a little bit of reading to do. We are talking about the depth of water in feet at a certain place in a lake. And it's modeled by the function W. And so we see the graph from 0 to 30. And the question is, so what are the intervals of t where the depth of water is increasing at a decreasing rate? So I'll let you all think about that for a minute. What do you think the answer to this question would be?
Do y'all want to try it in the chat or
Yeah, let's do it in the
everybody?
chat. It's coming. There we go. I know everybody's processing.
There we go. Okay.
There we go. Answers are coming.
Oh, look at our smart participants we have.
They are
Yay.
rocking it. I know this is great. So everyone is choosing A. Let's talk that through. So with my students, I would say, and I'm a big fan of highlighters. So I would say, let's get a highlighter out and let's mark everywhere that this graph is increasing. And so we would see that there are two intervals where the graph is increasing. And then I would say, now let's talk about what this phrase at a decreasing rate, what does that mean to us? And since we practiced that Quizlet, we know it means we're looking for a concave down section to the graph. So that's what we're looking for, the graph to be going up, but to also be concave down. And as you've all said, the interval from 3 to 6 is where that's happening. But a question like this is kind of a short sort of question, and once the answer is out, it's out. So what can we do with this graph and take it a bit further? So my next question would be, okay, let's forget that question. Let's think about this interval. We are looking from 6 to 12. How would you describe what's happening in this graph? And many times the students will begin with it is, and I'll say, oh, that word it. We don't like that word it. We want to get out of that habit right now. So let's start with the function is, and now I'd like you to finish that sentence. So if you could put in the chat, what's going on in this graph from 6 to 12?
You can abbreviate.
Sure, absolutely. Feel free.
Yay.
Very nice. Good, good. So the first thing we'll notice is this function is decreasing, of course. And then my next question would be, but how though? And so then we say, well, we see it's concave down, so it's decreasing at a decreasing rate. Fantastic. Okay, let's do one more of those. So what if we are now looking from 18 to 24?
Yay.
Got this, Vicky. Yes, that's right. So from 18 to 24, we see the graph is increasing. And we see also that this graph is concave up on this interval, so we can say it is increasing at an increasing rate. Beautiful. Well done. All right, so these are the kind of things we need to reinforce over and over and over so that our students just organically start talking this way, and they will, and it's really amazing how quickly it happens. But we do have to model those correct terms right from the beginning. Okay, so Vicky, it is time for you to talk to us about what comes next.
Okay. So when so I wrote a bunch of these things called Mix Six, and maybe we need to put the link to that somewhere later on, or we'll put it in the document. And I wrote a lot of them for AP Pre-Calculus. After the first exam last year, I realized in FRQ 1 a little bit and 2 more than the other one, students were having somewhat of a difficult time connecting this average rate of change and the secant lines and being able to talk about it. So the average rate of change is actually finding the slope of the secant line through 2 points on the curve. And then how does all this connect? So what I decided to do was to write, there are actually two mixed sixes that you'll receive in the documents. The first one goes with topics 1-1 through 1-4, which are kind of that initial part of the CED, kind of getting these kids used to that language. But I think it will help them a lot. They're given a single function, C of T, and a description, and then they have different processes to go through. If you're not familiar with a mix six, the first row essentially is fairly basic. The second row is really getting them to think and be able to talk about mathematics. This is a calculator active question, by the way. So they will need to use their calculator. But number one is factual recall. These are things we just hope they can say just almost instantly. Number two is carry out a procedure. Usually it's a kind of a beginner or kind of middle level question that they actually have to do some mathematics. The third one is classify. A lot of times these are like true false, Venn diagrams, like which ones are true, these kinds of things. Then you get to the second row, and by the way, this is following Bloom's taxonomy almost perfectly, in case you are wondering about where all this came from. But so number 4, students do have to explain their reasoning in many cases on the AP exam, and so this gives you an opportunity to have that happen in this question. Number 5 is kind of an extension of number 2, and I love the fact that they're kind of aligned vertically. So we do a whatever kind of basic problem. I don't want to say basic because it takes a little bit of work, but a somewhat basic problem in number 2, and then we'll go push them a little bit in number 5. And then, as I always tell people when I present a mixed 6, my favorite is number 6, critique of fallacy. You probably have an encyclopedia of ways kids can say things incorrectly, but be close. And so this is one of those times that we have someone who has said something and we've got to figure out what's wrong with what they've said. So this one is on those early CED topics. The second one is actually a similar activity with similar questions, but its own exponential functions. So if you've already moved past this, like you're some of those teachers that started in early August, and you go, oh, but I'm like almost finished with unit 1. Well, just wait. You can use the one with exponentials. This is the second one. Karen just didn't put a screenshot up there because you'll be able to access that document, we hope. Karen, but you were going to say something. I can't remember. We talked about you use this, or you were going to say a few words about it.
Yes, absolutely. So I was at the TI Summit in New Hampshire a few weeks ago, and I was talking about AP Precalculus and rates of change. And I actually used Vicky's Mix 6, and I asked my participants to do every single problem without writing mathematical work on paper, because I really wanted them to visualize what every question was asking. So I said, challenge yourself to do the entire thing on the calculator screen and visualize it, and then we will talk about what you would write on the paper. And it was really powerful for all of them to force themselves to think that way. I've done a lot of reading about how we learn mathematics, and believe it or not, we learn it visually. So whenever we can create the picture, that's going to bring it together. And I also have to commend Vicky on this because she is building a beautiful FRQ in this Mix 6. So even if you are done with topics 1.1 to 1.4, I would bring it back anyway. It's so rich, and the kids are going to really, really understand what that rate of change is telling them.
Thanks, Karen.
Thanks for reminding me of that. All right, are we ready to roll on?
Yeah, we are ready to roll.
Okay,
Okay, I am going to put
I got it in the
link.
chat.
So, oh, you've already got it. Look
I
at
got
you,
that.
how
Yep.
good you are. So the 2025 FRQs have been released. That's the link that will take you to those questions, those 4 questions. The scoring guidelines, the what are the other things? Student samples, the
Scoring
chief readers
statistics,
report, the
all
scoring
those things.
have not been released yet. Usually it's closer to the end of September before those are released, but just keep checking that link that she has given you, and hopefully soon you'll be able to see the scoring guidelines and different things. So this is FRQ2. One thing you might want to note is and we don't really want you to have to work this problem. We're just wanting to pull out some things for you to focus on. But where do you see rates of change anywhere? Secant lines anywhere in this, Karen?
Ooh, there's one right away in B1. So our students have been finding average rates of change all year, and then they get to the AP exam and they're asked to find one again. And then we
Another.
also see, yeah, they're asked to now use that average rate of change. So this is very similar to what happened in the Mix 6 as well. We're finding this rate, and now we're using it to do things. And then in part 3, we are also thinking about, so what is that secant line telling us? And if they can visualize that with their calculator, answering part 3 is going to be really easy. If not, they're going to struggle. So we really need to help them visualize what is happening when they're given a table of information.
Absolutely. And I think that's a powerful impact, what Karen did with and they were adults, they were teachers that she was presenting to. Um, I'm, I'm, I'm sitting here turning around in my head. Would I try that with kids? Maybe not at first. I've done things like don't don't do any of the math. First of all, just write down what you've got to find. Let's go through and talk about that, and then start doing the math, whether it's on your calculator or something that you have to do by hand. So I don't know, something that kind of has them doing it in phases opposed to just
Yes.
getting there and doing it kind of a thing. Does really help sometimes.
We were actually doing a question today that had a graph, and there were 4 different statements. 2 of them were average rates of change and 2 were instantaneous rates of change, and they had to rank them in order from smallest to largest. And they were all absolutely confused. And I said, well, why don't we draw those lines in? And so we did, and we got our Flair pens out and we made them all colorful. We drew those lines, and they said, oh, it's so obvious now. So they're just not used to making that visual component happen.
Yeah.
But when we keep nudging them that way, eventually then it happens.
And by
So
the
that
way,
was
Karen's talking about AP Calculus. They will eventually get to instantaneous rate of change, although we do kind of flutter around it with the AP Pre-Calculus.
Well, it was actually AP Precalculus.
Oh, it was Pre-Calculus. Oh,
It
sorry
was,
about
because
that.
they know what it is. They just know
Oh,
they can't
okay.
find
I
it.
got you.
Yes. Yep.
Gotcha.
All right. Shall we move on?
Yeah.
Okay. So in this FRQ, this is from the 2025 exam as well. Some of the other things our students need to be able to do, again, you see a table here, and we have a function. So FRQ1 will always have two functions given to them. One of them will be analytical, and the other will either be a table or a graph. So this year they were given a table. And in part B, they are asked to find where g of x equals 0. So two things are happening here. One is we're testing their calculator skills a bit, because we don't expect them to solve g of x equals 0 by hand, of course, but also to help them visualize where are the important points on this graph. When we look at that picture, what are we seeing? And then secondly, we are asking them to write or determine end behavior as x increases without bound. And the important part here is that we're using the mathematical notation of a limit, which I think is really one of the other powerful things about this course, is that we're not talking about just arrow infinity or arrow. We're actually showing them this is what a limit is, and this is how we write it. And when I talked to my friends at the reading this year, they were quite picky that all the parts of that limit notation were in the correct place. So that's important for our kids at this level, and of course beyond when they get to calculus.
So
This
Karen,
question.
hey, hang
Oh,
on
go
just a
ahead.
minute, Karen.
Sure,
So
sure.
I'm just to make sure that everybody did realize that we've actually answered somebody's question twice, myself and Mike. But this is being recorded, and you will be you'll get an email if you're live. You'll get an email notification that it's ready for you to view, and you'll have a link that you can get to the information. And even if you those who aren't here that signed up get the same email.
Absolutely. So all of the resources we're sharing, links we're sharing, will be available when you get that email. Yep. So this is a question from the CED, but it just kind of gives you an idea of how that end behavior may be asked when we're taking a look at multiple choice questions. So when we are looking at a polynomial, it's going to be important for our students to be able to look at P of X and say, what do I need to focus on? What is important for me to see here? And so we need to, first of all, help them to see, well, the degree is going to tell us a lot, because that's going to tell us that the ends will not be going in the same direction. The leading coefficient is always also going to help us narrow down, well, which way are they going? So that our students can then read that limit notation and interpret it as well.
And another thing that I will mention, students, go back to that slide just a second,
Sure.
is that it's always not as straightforward as this. Sometimes they'll say, as it decreases without bound or increases without bound, and students have to interpret what limit am I being asked to find. And those are very popular with polynomial functions, because we want them to have that connection to the end behavior.
And I think it's also very powerful to have our students define the function. Many times we're used to giving them the function and asking them about it, but also consider giving them the limits and asking them to provide a function that meets
Yes.
that end behavior, so that they're thinking of it in both directions. Okay. Also in FRQ1, we're taking a look at part C. And this is another one of the big threads that go through AP Precalculus, and that is modeling, but change is a part of that. So when our students are looking at this table they were given, they have to think about, well, what is happening in the inputs, what is happening in the outputs? And so you'll notice that part C is in two parts, and the first one is just saying, what kind of function would model the data we see in this table? So just like we practiced earlier tonight, our students need to take a look at those inputs and say, well, I see that they are all, equally spaced, of course. And then we're looking at the outputs and we're thinking, well, what's happening here? So this is a little bit further in. We're now into unit 2, of course, but we notice right away that our outputs are being cut in half. And that's indicating that we have an exponential function. So if our students just say exponential for C part 1, they will get that point. But then they get to part 2, and now they have to explain what's happening. And look at how this question's worded. Based on the relationship between the change in the output values and the change in the input values. If they just say it's being cut in half or something like that, that's not going to do it. They need to talk about what are the inputs doing and what are the outputs doing. So the sooner we get them talking that way, the better they'll be for FRQ number 1.
And it's easier when you're doing linear and quadratic functions and then eventually get to the exponential. I think one of the, and I'm just going to say this, I have not gotten to teach this course, but I've been very involved with this course and with a lot of teachers who are teaching this course. The students may not reach perfection with this language when you're in Unit 1, and you do not need to be concerned with that. You're building that vocabulary with them. By the time they see it again in Unit 2 and then again in Unit 3, they're going to become almost experts at it. So don't get stuck in Unit 1 thinking I've got to have them like they've got to be able to do this perfectly. So Karen, you can probably add a little bit to that.
That's absolutely true. And the first time I taught the course, I don't think I really understood these threads that go through it as well as I did the second year. But once I started realizing change, it just keeps coming back over and over and over. Then I could emphasize that for the students too and say, so now we have a new type of function. We're still going to talk about what is it doing? We're talking about its end behavior. We're talking about its rate of change. That doesn't vary. We always are going to do that regardless of the function. So then the students start seeing there's this continuity through the course that I'm always thinking about change, and eventually I'm thinking about modeling. Like what kind of real life scenario would be modeled with a function like this? So the great thing about teaching this course is no one ever says, whoever uses this in real life, because it's so obvious. It comes up all the time. And I think that's what makes it so valuable.
And also mention those of you who are not familiar with the free response questions. Number 1 and 2 are calculator active, which is why we were kind of looking at them a little bit tonight. One of the things students may want to do right off the bat when they're given a table of values such as this is actually put it in a table and let's see what the graph looks like. They should be able to get a hint as to what kind of function it is and what they are going to have to say in parts 1 and 2 of C, just if they look at that scatter plot.
But I will also say too, because once the students learn how to do regression on their calculator, they will want to do regression all the time for everything. So we need to remember that C2 is asking them to explain how they know. And if they say, I put it in the calculator and ran a regression, that's not going to do it. So they have to still be able to talk about the relationship they see in the table, even if they did run a regression to make sure it looked good.
Yes.
All right. Okay, whoops, I missed one. All right, I knew it was coming. There we go. So Vicki, would you like to talk about the link I'm about to put in the chat here
Um,
for the
yes.
YouTube series?
So,
Yes.
those of you who have been participating in the Thursday night AP Pre-Calculus sessions with Dr. Steve Kokoska and Dr. Tom, and I'm the silly sidekick. But anyway,
Hardly.
we actually, Karen's putting a link there. These are also recorded, but they're YouTube videos, and so you have access to them via the TI YouTube site. And we were supposed to talk about FRQ 1 and 2 Thursday night in late August, and somehow we only managed to talk about FRQ 1. So if you want a like super thorough discussion of FRQ 1 in all phases of the use of both the TI-Nspire and the TI-84, jump on that YouTube link.
Cool. Awesome. All right, Vicky, was there anything else you wanted to show us on the calculator before we get to our
I don't think
transition?
so.
We're all good? Okay.
Yeah, unless somebody has a request, but please don't do something weird.
All right. Well, what we're going to wrap up with today is, since I'm in my third year, and I know a lot of you are as well, I wanted to share the things that happened in my AP Calculus course last year that absolutely shocked me, that I wasn't really anticipating, and this is in a very good way, I should add. So when I taught AP Pre-Calculus this first year, I thought, well, we'll just see how it goes. And we got through it all, and the kids moved on to calculus. And oh my goodness. So stay tuned to what happened next. So the first thing that happened is this was at the end of the first AP pre-calculus year, and the AP exam had just happened. And this was a question on the AP calculus exam that year. So it's 2024. And it was about this coffee in a cup that was cooling down. And in part D of number 1, the students were given this second derivative, but then they were asked the question, determine whether the temperature of the coffee is changing at a decreasing rate or an increasing rate. So I had a student in calculus that year that was a complete rock star, but he came back and said, what was I supposed to even say? Because we weren't really talking that way in calculus yet. So I had some AP pre-calculus students in the room, and they said, well, what was the question? And he said, well, it was this curve and it was concave up. And so one of the kids said, well, if the graph looks exponential and it's decay, wouldn't it be decreasing at an increasing rate because that graph is concave up? And this just came out of an AP pre-calculus student's mouth organically. He just said it. That's how he was talking by this point in the year. And I thought it was amazing. So he felt like he knew something the calculus student didn't at that point. So that was cool. So they're using their words much better. And at the beginning, it's hard. Like right now, my students are struggling, but they'll get there, and they'll get that they talk that way just automatically when they see a graph, which is awesome. The second thing was talking about that definition of the derivative, which often looks like a big mess of stuff. It doesn't look like that to them anymore because they've been doing average rates of change all year long, and they know how to do that. They know what it means. So if they're given a table, no big deal. But they also know there is this thing called an instantaneous rate of change. They know they don't really know how to find it in AP pre-calculus, but it exists. And so when we get to calculus and say, all right, we're ready, we're going to now see that average rate of change, and that limit that you learned about, that's going to be the key that will get us to the instantaneous. It's so easy to make that transition. That was exciting too.
And Karen, I think the notation doesn't like throw them like it does the calculus student that never had AP pre-calculus.
Right.
It's, talking about that form of we know it to be a difference quotient in calculus is so new to a calculus student. But I just really feel like everyone that I've talked to that either taught both courses in sequence, AP Pre-Calculus that first year, followed by having the same students in the second year, or just having AP Calculus and having some of those students from another teacher in their class, they just saw the vocabulary, the notation was so strong with those students, and it made such a difference in helping them understand these sometimes kind of tough calculus concepts.
Absolutely. Absolutely. And speaking of tough calculus concepts, so Unit 5 has always been a tough one, right? I mean, there's a lot in Unit 5 in calculus because we're talking about rates of change, we're talking about concavity, we're talking about the first derivative test, the second derivative test, all the things. There's just so much. And it really is hard for the kids to look at a graph and understand what that's telling you about a derivative graph or a second derivative graph. And it's always happening for me right around Christmas time. So the kids are just kind of tired and ready to be done. And it's always just hard. This past year, I said, okay, we're going to do something. I would like us to draw us a curve, a nice polynomial curve, and let's get our markers out and let's write down everything we can say about that curve that we learned last year. So we labeled where it was increasing and we said why, because as the inputs increase, the outputs increase. We said where it was decreasing. We talked about the absolute and relative maxes and mins. We talked about the concavity. We talked about the inflection points, and we labeled it all with different colors, and we described it as we did in AP Precalculus. And then I said, okay, now what we're going to do is keep all these colors, but now we're going to bring in our derivatives. So instead of saying, we know this function's increasing because as the inputs increase, the outputs increase, we can now say because f prime is positive. Or we know this is concave down because f double prime is negative. And so they labeled their graphs. And so these are two examples of what they did. And I will tell you that teaching Unit 5 has never been as easy ever in my career as it was last year. And it's all because of the foundation they received in AP Pre-Calculus first. It was amazing.
And it's all about rates of change, Karen. I think,
It's all about rates of change.
I'm going
It
back to
is.
the title of our webinar tonight. Understanding that idea of rates of change and the connections to what a graph looks like, what a graph is doing is just so important. And it makes it so much easier for these kids to transition from that rate of change to this idea of a derivative.
Absolutely. So that was amazing. So of all of the things, I think this is probably the most significant to me because I didn't expect that, but it happened and it was amazing.
And the fact that they remembered it is what's really nice.
They did. So our last effect that we'll talk about before we get to the webinar drawing was my Jello egg lab. So when we get to Unit 8 in calculus, we're finding volume. And so I always do my lab with the Jello eggs so they can actually see what those discs look like that we're talking about. So I brought the Jello eggs in last March. And so the kids got their centimeter graph paper that you can see here. And one of the things they have to do is trace the egg and then get some data points from that graph, and then they put them in their calculator. And so regression was kind of in their back pocket too because of AP Precalculus, so that was good. And they would create a function for the egg, and then they would do their disk method and get volume number 1. And then at the same time, there were students who were submerging the eggs in water and just looking for displacement, so that was their volume method number 2. And then finally, we got the egg slicers out. And so they would actually slice the egg and be able to see all those discs, and they would measure those and add up all of those together. So those are the 3 different volume methods that they would do for this Jello egg lab. So anyway, so as we were going back to that first method though, where they were tracing the egg and trying to find these data points, and they'd say, well, what kind of function should we use? And I say, I don't know, you're the scientist, so what do you think would be best? So one of my kids said, well, could we just run a residual plot and see how this fits? And I looked at him and said, yes, you can. But no student in calculus had ever asked me that question until last year because they frankly didn't know what residual plots were or what they were for. And so this is the student's graph where he decided, yep, this is a really good fit for this curve. I'm going to go with it. So those are the kind of things that just happen on a daily basis in calculus where I say, wow, so glad you took AP Precalculus. Vicki, would you like to add anything else before we wrap up?
Yeah, why don't you share with the group, just for a little funny for the moment, where you took Jello eggs for a presentation?
This summer, I was doing a summer workshop in Indianapolis. And this time they decided to make it sort of conference style so that participants could bop around to different sessions as they chose. And so one of my sessions was bringing food into your AP Calculus classroom. And I thought, well, I've got to take Jello eggs. So I made Jello eggs here in Michigan and drove them down to Indy. And yep. And so Vicki texted and said, I heard you have Jello eggs in Indianapolis. I said, yes, I do. And we all did the lab. It was awesome.
But we're going back to this idea of hands-on and how valuable the visual effect of this is on students. And it just, I don't know. I'm a visual learner, so I appreciate it so much, but I feel like a lot of our students are too. So I'm going to go back. Help them visualize rates of change, help them visualize secant lines, and then help them understand the connection that they have with their AP Precalculus, because it will make a world of difference when those students move to their AP Calculus teacher the next year.
Absolutely will. Awesome. All right, Mike, somebody needs to get a cup of
All right. Thanks so much. I wasn't hungry until I saw some of this.
Thanks.
Now I'm hungry. So I know that we've done some mentioning about some of the other events that we have, but I just wanted you to have a slide for that to kind of summarize it all, in case you were looking to attend some of our future events. The ones on YouTube, and Vicky, correct me if I'm wrong, not that they're not geared for teachers, but they are really geared essentially for students, right? But
Yes,
teachers attend as well.
yes, we really want to have students. What is actually the most ideal situation in the world is to have a teacher and a number of their students on at the same time, because I think that interaction with their teacher is just so valuable. So we want students and teachers on the YouTube Thursday night AP Pre-Calculus.
Awesome. All right. And finally, the webinar drawing. So we are giving away one lucky winner, a TI graphing calculator of their choice. Tonight's lucky winner is Marlene Behrens.
Yay.
Yay, congratulations. Yes.
Yep. Start thinking about which calculator you want. I'll be reaching out to you over email soon to get some information. So congrats again. To receive a certificate of attendance, copy the link that's coming in the chat window. Also listed is a link for the documents for tonight. And I just want to mention one more time that although, yes, you can get those documents, especially if you're a TI-84 user, I think you're going to want to maybe hold off or maybe re-download the documents in a day or two whenever they come out, whenever Vicky's going to update with screenshots for the 84, which I appreciate. And if you're watching this on demand, copy that link into your favorite browser to receive your certificate. If you have any questions, maybe we missed a question during the webinar, give us a call at 1-800-TI-CARES or send us an email, ti-cares@ti.com. We'd love to help you out. Last but not least, when you leave the webinar, a brief survey will automatically appear in your browser. And these surveys are super important for us. They really help us plan our future online events. And so if there's something that you saw that you are like, man, we need to do a part 2 of this, let us know. And if there's other stuff that you're like, I've never seen you guys do anything on whatever, let us know that too. We'd love to create some content for everyone. So huge thanks to Karen and Vicky for everything they shared tonight. Whether you at home realize this or not, these two ladies have just a ton of math, calc, pre-calc, firepower. So you guys are lucky to have them tonight. So Karen and Vicky, thanks so much for everything.
You're welcome.
Thank you, Mike.
And thanks everyone that took some time out to join us tonight. It was fun for me. I hope it was fun for you. And we'll see you back online hopefully next week. Have a great night.